Hello, I'm Emin Erdem Kumbasar. I'm from Bilkent University. Today I'm going to talk about my Physics 101 project. My project is about circular motion, and in my experiment I use dough to create masses in both sides of the rope and a rope. Then I used a glass tube to hold my rope in the experiment. And to measure the radius of the motion, I had a ruler, and also to measure the masses of the balls, I use the balance. And finally, I use my phone stopwatch in order to measure the period of the circular motion. So my experiment works like this, and as I spin the ball, it creates a circular motion, and this applies a centripetal force to this motion. However, when I spin it faster, this ball rises up in order to create an equilibrium, and also when I slow it down, it lowers down. So my goal in this experiment is to find the equilibrium position where this mass will be in the same position, and where it wouldn't rise up or lower down. And then I will measure the period of this motion. However, to get more accurate values, I will measure 10 rotations of the period. And also, after I finish the motion, I will stop it like this and find the radius of it. So after I measure 10 rotations, I divide my values by 10 in order to get the period value. And for each mass value, I will repeat this 5 times in order to get more accurate values, and I will use the average values of those measurements. And then I get these values, which are for 10 gram of the heavier mass. Using stopwatch, I had 0.6 seconds as my period. However, when I use my the radius value to find the period by using formulas, the period value was 0.64, and the percentage error was can be it was a little bit low, which was 6.25. However, in some mass values, it was a little bit higher, where for example, when I had 30 gram of mass in the bit below of the rope, my percentage error goes up to 21.2%. This may have been because of the my measurements on radius, since when I'm stopping the rope, it may have slipped down or up, which may have caused the values to be wrong, or maybe my reflexes were a little bit slow when I was measuring the period with a stopwatch. And to explain the relationship between the mass and the period, I drove a graph, as you can see here. This graph is mass versus the square of the period. So as you can see, it's a linear graph, and they are inversely proportional, where, for example, when the mass increases, square of the period decreased in the same proportion. So I think this proves my goal in the experiment, which was to explain the relationship between the mass and the period, since when I used the formula, the square of the period was inversely proportional to the mass of the ball, which was causing the centripetal force on the motion. So this is my experiment. Thank you.